Ich habe für mich mitgenommen, dass es außer unserem Projekt auch andere interessante Wasserstoffzugprojekte gibt und dass ich mich glücklich schätzen kann, an so einem erfolgreichen teilzunehmen, weil es unglaublich von Randbedingungen abhängt, ob so ein Projekt dann läuft oder auch nicht so gut läuft.
Thank you for the introduction and for the opportunity to talk here about this European project. I'm going to talk about the development and demonstration of a bi-mode fuel cell train, which is a difference to the Stadler train that we have seen just before. How comes that DLR is talking about this? We are German Aerospace Center. Of course, we are talking about aeronautics and space, but we are also doing energy and transport as one of our, or as two additional research fields. And as a whole, in DLR, we do a lot of hydrogen research already. So we used it as propulsion fuel for rockets, but we are talking about generation of hydrogen, like shown this morning already, I think, or in the beginning, about storing hydrogen, about using hydrogen in the end in the mobility sector, and this is where I am working on. I come from the Institute of Vehicle Concepts, one of 30 institutes, and this is one of the pure transport sector institutes, so we are working on starting from bicycles to trains, everything that has wheels is on us, and one of the topics is especially alternative drives in all these technologies or in all these vehicles. Coming back to the topic of railways, why do we talk about hydrogen in railways? So in Germany we have at the moment like 2,900 diesel multiple units that are there, so the CO2 of these ones, the CO2 emissions is quite high. And this is the point where electrification is often not the most economic thing, so we need to think about different solutions. Another topic is shunting locomotives, so 2,800 locomotives in Germany. Average age is 42 years, so you can imagine it's not the newest diesel engines that are used there and maybe not the cleanest ones. So it's not as visible as, of course, passenger transport, but anyway, we need to do something. And we had the chance to send a proposal for a European call, which was coming out from the Fuel Cell and Hydrogen Joint Undertaking, which is now Clean Hydrogen Partnership. And it started in 2020 to prepare the call, and the project we won in the end started in 1st January 2021 for 4 years. And we are a consortium of 8 companies and partners. We have Toyota as a fuel cell manufacturer in the consortium. We have CAF as the train manufacturer, who is one of the biggest partners. We can be glad that we have Renfe as an operator who provided a train that we can use as a demonstrator. We have the 2 infrastructure managers from Portugal and Spain here, so this helps us, of course, for all the authorization topics and driving on the public network. We have the National Hydrogen Center and DLR as research organizations, and Stemman, part of the WAPTEC company, which is on the one hand working on pantograph topics, and on the other hand, Favile is working on climate topics. Because we have some of the objectives also think about finding additional solutions to use waste heat in fuel cell drives, and also to use other hydrogen-driven HVAC components in the train. The most important objectives in the project are to develop, build, test and homologate a multi-purpose fuel cell hybrid power pack, and to demonstrate it in a bi-mode CVR multiple unit. So on the left-hand side, this is kind of such a power pack, how it could look like. And on the right-hand side is the train that we defined in the beginning where we want to integrate it. I just jump over that one. We started to evaluate all the requirements for different countries, in that case for Spain, Portugal, Germany and Slovakia. So we analyzed the diesel lines that are currently used and the typical services there, and then we choose the most important services which are either going in special slopes, very high altitudes, or high speeds or high ranges that are needed. And from these analysis of boundary condition and requirements, we derived the requirements for this fuel cell hybrid power pack. DLR was engaged here in doing all the service profile according to EN 5591. And we also started in the beginning with thinking about the H2 refueling. So there are different options on the train. We could go for 350 bars, 700 bars, or liquid hydrogen. Here in that case, we decided to go for 350 bars. But it's also a question of how to supply hydrogen to the train and what is needed as a hydrogen refueling station. And as you said before, in Switzerland, there is no adequate infrastructure for hydrogen refueling. We had more or less the same problem in Spain. And it's not easy to rent something, so it wasn't the goal of the project to develop a refueling station, but we had to in the end because there was nothing available that we could use. Okay, the fuel cell power pack itself, the idea is to have it scalable and modular so that we can use it not only in this specific demonstrator train, but also in locomotives, in shunting locomotives, and as a refurbishment product for other trains that, well, come to the end of life or have already electric drive by diesel and shall be reconverted. The components come, as I said, from Toyota, the fuel cells. The energy storage system comes from CAF. The DC-DC converters also from CAF. The energy management system, which combines the driver assistance system with the controls of the hybrid system, is also made by CAF. And the cooling systems and the storages for hydrogen are third-party products. As you mentioned shortly, the energy management in such a hybrid thing is quite a complex topic. So this is taken from the EN50, from an EN norm. On the right-hand side, you have all the consumers. So tractive effort, clearly traction equipment is consuming a lot of power. But also the auxiliaries and the HVACs are consuming power. You can get some of the energy back during braking. So if you have a pure battery train, it would be a configuration like this one, where the battery is doing everything. In case of a fuel cell hybrid, you have in addition the fuel cells that can do something, and now you need to choose who is doing what at which time during the operation. But not only during the operation, also when you build the system, when you design the system, you have to think about which amount of power is coming from the batteries and which is the amount of power that comes from the fuel cells in the end. In our case, we would also have, as we are a bi-mode train, we also have the catenary and a pantograph there. So it's not our intention to use all three of them at the same time, but the batteries are charged during operation under catenary, and we can drive and use the overhead line with that kind of train whenever it is available. The challenges are, as I said, the design and dimensioning of fuel cells and batteries on the one hand, and on the other hand, how to work with them if they are built in the train, how to operate them properly to reduce the energy consumption. From DLR side, we developed two tools and validated and applied them in the project. So we have a so-called hybridization tool, which uses a simple control strategy to get the dimensioning of batteries and fuel cells. And on the other hand, once the train is built, we use a tool called Smart Energy and Speed Optimizer for rail, which is able to optimize the speed profile together with the controls of the fuel cells and the batteries in a way that you always have enough power and enough energy available by also influencing the drive power you need, the traction power you need by influencing the speed profile. So this is now more or less what we really did in the project, or the other partners. This is a picture of the fuel cell system. It's a second generation fuel cell system from Toyota, the same that is also used in the actual Toyota Mirai, but of course in a little bit a different layout. These are one of the two energy storage systems provided by CAF. And this is one of the 4 racks of hydrogen storages that are brought to the vehicle, well, with very complex piping, as you can already see here. Everything had to be tested with the controls before, so CAF built a hardware-in-the-loop test bench, especially to show or to test the integration with the train control and management system before it was really operated in hardware. One of the 2 power packs used for the train was built outside the train here in CNH2's facilities in Spain. So we started in February 2022 14 months after project begin, with building up the first power pack, 3 fuel cells with their cooling systems, the hydrogen monitoring and supply panel, and also one of the storage systems, and a big DC-DC converter to put everything to the 3 kV DC voltage of the train in the end. This test program was, on the one hand, testing the components, but also consumption tests according to standardized profiles by the European Joint Research Center, drive cycle tests, ramp-up tests, and specifically created tests from our use cases and service profiles. And as a result of these tests, we consumed more than 220 kilograms during testing of hydrogen, and we got a detailed knowledge and could, of course, optimize the whole energy management system and prove that the system is working as expected. The other topic was to develop the train demonstrator itself. So this is the CVR3 car that we got from Renfe as a basic electric train. And the aim was to have this one made out of it, a hydrogen train, still having the pantograph equipment there. So we started with the development in 2021. We started with the testing in 2022. In parallel, the second power pack was integrated to the train, and first static tests were done in beginning of 2023. Static test means the train was standing or driving on a closed area. And in May 2023, we received the first authorization to travel on the Spanish network with the full train with both power packs. One of the topics, as I said before, was the refueling of the train. So what does it take to refuel such a train? On the one hand, you need the dispenser unit itself with the lots of valves and safety equipment and so on. But in our case, for 160 kilos per day, the system that was created in the project consists of 4 such containers. So 2 storage containers, 1 compressor container, and 1 dispenser container. And all of this has to be operated to use the train. Yes, at the moment, or for the demonstration of the train, we could only use the dispenser with an overflow filling. And now, as the train demonstration is already done completely, the aim of the project is to validate the full refueling station, which we will do this year until the end of the year. So I have also some pictures, hopefully no sound. So this is part of the testing in Puerto Llano with the fuel cells there, the battery systems that have been on the train. And in parallel, the HVAC systems have been dismounted from the roof, and fuel cells and their cooling systems have been mounted on the roof of the train. The energy storage systems have been brought to the middle car, so all the seats have been taken out, and batteries and tanks, hydrogen tanks, have been brought to the middle car. And then we started our first tests on the line from Zaragoza to Canfranc in the Pyrenees. So it went steep up to 1,200 meters. And as you can see, no catenary, no choke. It's purely hydrogen driving there, even in these demanding lines. Yes, in the meantime, our whole testing program has been achieved. So we have not only been testing on this line. We had 4 other lines in Spain and 1 in Portugal, making this train not only the first hydrogen train on the public network in Spain, but also in Portugal. We could also do an autonomy test, which was in our case 800 kilometers on hydrogen purely, plus unlimited with the catenary, of course. I was asked to put together some of the facts. So the train demonstrator itself is a 3-car unit with the 3 kV pantograph DC system. The energy storage systems range up to a max power of more than 1 megawatt. Not on the wheels, but of course on the energy storage. Quite small compared to the power they can deliver. We have 6 of those 2nd generation fuel cell modules from Toyota, which are rated 80 kilowatt each. and 160 kilograms of H2 storage on the vehicle. In our case, it's Type 3 storages, which is not so critical for refueling, like the Type 4 with the temperatures. And that's good because we have higher temperatures in Spain and had higher temperatures during testing sometimes. Yeah. We have been driving now more than 10,000 kilometers in hydrogen mode, about 6,000 in electric mode, consumed roughly 2 tons of hydrogen, and could prove this autonomy of a little bit more than 800 kilometers. Yeah, that's it so far as a short overview. If you are interested, you can have a look in all these videos on YouTube where a lot of the different phases are described. And that's it so far from my side.